Hello there, it's time to look at standard deviation. First of all, let's think about the skills that we will need. First off, you have to be able to find the mean average. In short, this is where you add all the numbers and divide by the number of numbers. Secondly, you have to be comfortable with squares and roots, so stuff like 3 squared is 9, square root of 9 is 3. Usually standard deviation questions will be done on a calculator, so make sure that you know where this square root button is on your calculator and how to use it. And finally, you have to be able to substitute into a formula or into formulae. This is where you replace letters with numbers. Okay, now understanding standard deviation, aka what is standard deviation? The standard deviation is a measure of how far on average the pieces of data are from the mean. It's a measure of variation, which is a good word to remember. So for example, if you go to the shop and you buy a can of Iron Brew, and on that same day you go to loads of other shops and buy other cans of Iron Brew and compare their prices, if you are just looking at the prices from, say, supermarkets, they will probably all be the same price or close, in which case there'll be a low standard deviation. There isn't much variation in the prices. But if you go around loads of local shops or garages, places like that, and buy cans of Iron Brew, the prices might be wildly different, in which case it will be a high standard deviation because there is more variation in the prices. Okay, now let's look at how to calculate standard deviation. Okay, just as a fair note, the sum for standard deviation does take up quite a lot of space, so if you're at the very end of your page, you might want to get a new page for this one, because it does take a good page or half a page. Okay, so if we have various different Iron Brew prices, so I go to 4 different shops and I buy 4 different cans of Iron Brew, they cost 80p, 89p, 56p and £1.15. The first thing I'm going to want to do is calculate the mean of these prices because I'm measuring the variation from the mean. It's normal when we're doing standard deviation to call the mean x bar. So it's x with a line on top, you say x bar, and that means the mean. Okay, so we add them all together, divide by the number of numbers. The total of all of these prices in pence, being careful of this one, is 340 pence. And I'm going to divide by 1, 2, 3, 4 because there's 4 pieces of data. And that gives me a mean of 85 pence, which roughly makes sense. If you look about the average of these, you're like, yeah, that one's close to 85. These two are kind of close to 85. This one's way under, this one's way over. So 85 intuitively sounds about right. Okay, next bit, we're going to set up a table. Okay, here's our table. Our columns are x, x minus x bar, which remember is the mean, and x minus x bar, all squared. The x's are just your pieces of data, so you can fill that in first. Okay, next, x minus x bar is as it reads. You take x and you take away the mean from it, so it's the difference from the mean. Some of these numbers will be negative. So 80, take away 85, that's going to be minus 5. 89, take away 85, positive 4. 56, take away 85, negative 29. And 115 take away 85, positive 30. At this point, you might want to do a quick check. These numbers should always total 0 if everything is going well. And they do, so that's great. Everything's going well so far. Next, we're going to take our x minus x bar from the previous column and we're going to square it. There should be no negative numbers in this column because a negative squared or a negative times a negative becomes a positive. So when you're typing it into your calculator or doing it in your head, it's up to you. You can just ignore the negatives. If you are putting it in your calculator with the negatives, some calculators will require you to put a bracket around the negative so that you get your positive answer. Just remember, answers in this column, always positive. 5 squared, 25. 4 squared, 16. 29 squared, 841, and 30 squared is 900. Okay, now we're going to total these, and we get 1,782. The point of this table is to get that number there, so it's worth thinking about what that number is. What did we do to get it? We added up, so we did the sum of the x minus x bars squared. Let's remember that, it will be useful in a second. Okay, now I'm about to show you the formula for the standard deviation. Do not worry, it's gonna look a bit complicated, it's not as bad as it looks, and you don't have to remember this if you're doing Nat 5 maths or applications or anything like that. It will be in the formula sheet if you're doing this for an assessment. You don't have to memorize it. So standard deviation, one of the formulas for it is, okay, so it's big square root that covers both parts of the fraction, of the sum of the x minus x bars squared over n minus 1, where n is the number of numbers, just like you have in the mean. Okay, let's substitute into this formula. So first thing, we're still going to have our big square root over the whole fraction. The top of the fraction, the numerator, the sum of the x minus x bars squared. Where could I possibly... Oh my gosh, that's the whole reason we did the table. Okay, so I take the number from the total of the table there, and that's the whole numerator of that fraction. Then I put it over the number of numbers minus 1. So I've got 4 numbers, take away 1, that's going to be 3. Slam that into a calculator and I get something like 24.3721. Blah, blah, blah. And I'm going to round that to 24.4. Okay, and that's how you do the standard deviation. If this is for National 5 maths or applications, you get 4 marks for this. You get 1 mark for working out the mean, you get 1 mark for a correct table, you get 1 mark for correct substitution, and you get 1 mark for a final answer. So 4 marks, quite a bit of working. You do have to remember this table, you don't have to remember this formula, but overall they're a good straightforward 4 marks to get. And if you're thinking of going into anything to do with statistics, so biology, psychology-based sciences, any sort of economics, marketing, finance, things like that, this will be a really useful skill in the future. It's worth noting that this standard deviation formula here is only really good if your mean is quite nice, as in it's not got loads of decimals. There is a slightly different formula for if your mean is horrible looking. But first, best get some practice on this. Happy standard deviating!